you feel my mind, or you feel my mind. We could build a dream, start up something new, and the world is on your shoulders, and you feel like falling over. Just let me in your head, so I can be there for you, there for you. The night is young, won't you sing for me? Won't you sing for me? Till we fall asleep.
Hello, everybody. Welcome to VC Masters on the Pod TV network. I'm Nick Palavita. I will not be your host for today's presentation. Instead, we have, of course, Dr. Salman Azhar, who's a professor at Duke University, who's going to be introducing a very special guest who's been on the network before many, many years ago. And so without further ado, we're going to bring in Dr. Salman Azhar. We're going to have a very exciting show today because Julien's on, who I knew as the genius of the year in 2017. That's kind of like his big CV. But anyway, it's going to be an exciting show. So Dr. Azhar, you're going to take it from here.
Hello. So we have a great show here today. It's about going to be AI, which is one of the hot topics, but a lot of people are having challenges of understanding what AI can and cannot do, or even using and where to get started. So today you will learn a little bit about that, at least to get started. And we have Julien Arpin as a guest today, who is a boy genius that Nick met a long time ago. And as you can see, he's a little bit more adult genius now. Julien, you have an interesting background. Can you tell me a little bit about more what the dots and Mona Lisa and like all that stuff is going on there?
Definitely, Azhar. Thank you. So what you see behind me is called a knowledge graph. It's also called a mind map. And it's from a tool I'm building. I'm happy to show you guys here shortly, called Newton. I inputted an image of the Mona Lisa, and Newton analyzed the image, extracted descriptive details, and constructed a knowledge graph of those details. So the dots represent the details, and the connections between them are the conceptual links between the ideas detected in the Mona Lisa.
Fascinating. So if you take that knowledge graph, it has a knowledge to construct Mona Lisa. So I've heard of text to image. This is kind of image to graph. And where does that come in that overall from a perspective from a user experience?
Yeah, great question. So from the user experience, you would just paste in an image, import an image. There are a few ways to drop in any file type. What happens is the system will use vision-capable AI systems to analyze the image and generate text-based descriptions. And then those text descriptions are what are used to generate the graph. So there is an intermediary step there where the image is converted into text. And in fact, I'll show you shortly what that looks like in the back end. You can cycle back and forth between the image and the description of it.
Fascinating, fascinating. So what is the core problem or inefficiency that you observed that led you to create Newton?
So interesting question. Ultimately, it was the desire to help someone close to me structure their writing, their essays. And so as they were writing, I thought it would be helpful if they could see the conceptual connections of their writing visualized beside their written document in real time. And so as I began constructing a solution to that problem, I realized just due to the generality of language, its all-consuming nature, a kind of focal point, a bridge between every area of human thought, there was a lot of potential to make more things happen. And so it began like that. I realized, okay, you know what? We can make it to where you can click on a node. There's a tool in Newton called the idea generator. You trigger that tool, a bunch of thought bubbles will shoot out from the node. And in so doing, the AI prompts the user to dig deeper into their own critical thinking, to explore the topic that they're writing about. So instead of the user just having AI do all the thinking, the AI guides the user, and then they can see the richness of their own writing in real time. So as you write in Newton, the graph changes to reflect the writing.
Awesome, awesome. So for someone seeing this for the first time, like many of our viewers would, can you explain what a knowledge graph is? And what's a more powerful way to view information than a simple, why it's a more powerful way of viewing information than a simple document? A lot of our people may understand graphs as like y is equal to x squared and so on. And the kind of graphs you're talking about are fundamentally different types of graphs. Please tell us more about them.
Yeah, absolutely. Great question. So a knowledge graph, they used to be called mind maps. Knowledge graph is the more technical term. There's a lot that goes into it, but ultimately it's just ideas connected by lines. Nowadays, these things are making a bit of a return because the fact that AI systems often leverage knowledge graphs. So for example, Google, it uses an algorithm called PageRank, where the priority of a page is determined by how many other pages link to it. You could think of each page as a node in this network, this knowledge graph. And so the more edges that connect to it, the more priority it has, the more importance it has. So it's great for being able to prioritize networks in that way. As networks evolve, you can use the neighborhood level feedback to prioritize a hierarchy of things. And it can also help you to ground information contextually. So you can look for a direct text match from some structured database, but by having this background information and seeing how nodes connect, then you have a much richer understanding. It's a bit closer to our dynamic world in terms of changing circumstances. It's cool that you use the word view, because AI systems don't necessarily view the knowledge graphs, but as human beings, a large percentage of our brains are dedicated to visual processing. So it's a great advantage for us to be able to leverage knowledge graphs in a visual manner. And that's also something I'm excited to show you shortly, because you can take a massive amount of text and Newton can summarize the key points, convert that into a visual representation, and the human brain is perfectly geared to be able to absorb that in rapid succession. And so you can just tear through things that would normally take much longer to learn, understand the key ideas, and then if you wanted to go and read it the long way, you would most likely retain a lot more information as a result of having that mental scaffolding.
Awesome. So if I look at the bottom right, just on the right of your neck, I see a dot that is brown and a dot that is black. Those are nodes, I believe. And then the line that connects them is the edge. So what you're telling me is that when I see that brown dot and the black dot are connected with a line, that means that there is some relationship between them. And anytime a dot is connected by a straight line to another one directly, that means the relationship is close, a relationship. And then if you can traverse through many different dots to get to another dot or another node, that means that there is a relationship, and the farther away it is, the less of a relationship it is. Is that a right way of looking at it?
Absolutely, yes. And there's a bit of a philosophical problem in terms of, well, isn't everything technically related to everything? Yes, but that's also the key in terms of establishing understanding, is knowing when to say that this thing matters in a certain context. So you're absolutely right. The different colors of those nodes reflects different categories of the nodes themselves. So as you generate these graphs, different types of information will be put into different categories, and then they have their colors.
Awesome. So, a lot of us are familiar with the 7 degrees of separation, and Kevin Bacon is sometimes used as a kind of thing that all the actors are connected with Kevin Bacon by 6 degrees. Well, yeah, 6 degrees, I guess. And that means that if two actors, an actor acted with Kevin Bacon in a movie, they have 1 degree of separation. And if any actor acted with a movie that Kevin Bacon acted with, there's another degree of separation. So that's kind of like the actors become like nodes. And if they act together in a movie, that becomes a line that directly connects them. And if they acted with somebody that acted in another movie, then it is a 2 degree of separation, and so on. And then in some ways, yeah, you're right that everybody is connected. If you take things far enough, up the chain of the hierarchy, everybody is kind of related. But then the degree of relationship that I may have with you would be different from the degree of relationship I may have with my son, or with my cousin, or with my second cousin, and with my great grand uncle or great grand kids when they are there, and so on. Oh, wonderful. This is an amazing way of kind of looking at it. And then you also mentioned that the computer doesn't quite see the graph like we are seeing it. How does the computer see the graph?
Okay, so it uses proximity, numerical representations of proximity between ideas. So when we look at these things, we can see, okay, on this flat surface, XY coordinates, such as the web page behind me, this node appears to be next to this other node. Maybe there's some similarity there. A computer would see something like a numerical representation. So it would say, oh, yes, this does indeed have a pointer to this other node. And then depending on the architecture, there may be something like a kind of cosine similarity, which assesses the distance between nodes. And when cosine similarity comes into the picture, this is where you might have heard about embedding spaces. These things are all the rage with these large language models. Ideas that cluster together are more similar. So for example, cat and kitten would be closer together than cat and dog, but cat and dog would be closer than cat and house. because cat and dog are both animals. And that's just a general rule of thumb. You can always try to shift the dimensions a little bit, the coordinates, but ultimately the computer will see numerical representations, and then they will look at similarities in space in terms of X, Y, Z, however many dimensions.
Awesome. So what you're saying is that, let's say if I have friends and I'm directly connected with them, there is kind of like we are both those nodes or circles. And if there is an edge directly connecting, then I'm a direct friend with them. But then there may be a distance factor because I may have some close friends and I may have some distant friends. And then I may have some friends and friends that are even more distant than the distant friends. Did I capture that idea correctly?
Yeah, that's exactly right. So if you didn't have some kind of representation factor that would adjust the distance between nodes by some arbitrary unit, such as, for example, in Newton, the connections actually serve as springs, and there are physics simulations engines, so there is a bit of a gravitational pull. But if everything was just taken by default, node, maybe kind of square grid, then yes, your direct friends would be a lot closer to you, unit by unit, than friends of friends, just because they would be next to you. But whenever you have something like Newton, for example, you might see there are sets of nodes that don't necessarily point to each other, but just due to the gravitational constraints, they end up appearing nearer to each other. And that's more for our own benefit so that we can process it.
Awesome. You know, I'm an undergrad math and physics major, and what I have seen is that physics has been really helpful for me to understand a number of things, because a number of things that I can't visualize in real life, I can visualize through physics, like the spring you were talking about. Is something I can visualize. Now, gravitational force I can't visualize, but I can see the gravitational force acting, so that it may pull things closer or farther apart depending on how that thing is acting. And and it's just so fascinating to see physics in all over the place. So for anybody watching, take at least one physics course. It will be really helpful for you, because it gives you both the right brain and the left brain part working together. But let's step back.
I gotta say, physics is the art of modeling things. So it goes so far beyond just the math that people may consider. And whenever you learn how to build mental models, like you said, it really is all consuming.
Yeah. And if you really want to have fun, take electromagnetism class, because that's where I felt that everything came together in terms of the abstract and the real. But I don't want to digress. I want to step back into Newton for a while. Physics, Newton. That's interesting that you named it also Newton after a physicist.
Right.
So let's talk about just some of the basic. How does a user get their own text into the canvas in your system?
So there are a few methods that they can follow. The first and most direct one is to type into the document area. So the document area isn't shown in my screenshot. It is, but the document area currently has an image. So you're able to go to this drop down and you can switch between different input types. So if you switch away from image, I think it's cut off, so you may not see that drop down I'm talking about, but just put it in something like plain text or markdown, then the user can type directly. And as they type, the knowledge graph will spawn and evolve. And then they can also import pre-existing files. And so all sorts of documents are compatible: PDF files, TXT files, markdown files. You name it, you can drop it directly into Newton, even spreadsheets. So either type it directly or input an existing artifact and you're good to go.
I'm an undergraduate physics major and also a spiritual person, so I believe things that I don't see sometimes. So I can see that drop down or imagine that drop down even though I can't see it.
Good. Sometimes those are the realest things, The realest things are always true. Historical things are true once, so you get to decide how to prioritize their importance.
Yeah, one of my professors said that infinity is a concept like love. So, that kind of like put infinity into perspective. But let's go back to Newton. I see options for importing files, and what type of files can Newton handle?
So very many. I already listed a few of them. You can even drop in MP3 files, MP4 files. Newton will extract transcripts in order to construct the graph. You can put in image files, all sorts of different image types, as you can see there. So in general, really anything you could imagine you can drop in. I would say the only thing that it can't receive right now would be a database file, but otherwise it is exhaustive in its ingestion capabilities.
Awesome. The URL import feature is particularly intriguing. How does that work? Let's say if I want to import a technical article or GitHub repository, which is like a repository of computer code, or a Reddit discussion, how would I do that?
Right. So in the same menu where you're able to import a file, which again isn't shown in my background, there is a bar that you can input URLs into, and Newton will go to the web page that you input and extract the content. Newton's pretty smart. So depending on what it is, it may just do a kind of blind sweep of all the data that's there. But if it's something like a GitHub repo, you drop a link to the GitHub repo, Newton will map all of the files and directories from the root folder so that you can see the layout of the entire code structure in that repo. If you drop a link to a Reddit post, Newton will pull the original post as well as all the comments and instantly map everything, essentially solving the TLDR, too long didn't read problem. And you can just go through hundreds of ideas, dense text in just mere seconds. It's really great. Extract the core ideas. Or you can put in a YouTube videos link. And whenever you drop in a YouTube video link, Newton will take the transcript of that video, no matter how long it is. Only takes 3 seconds. You have a knowledge graph. You can see all of the information that's there. And there's an important tool in Newton called Deep Dive or Expand Node. And whenever you select a node and then trigger this tool, the system will review the entire document of text, look for any background information, and then it will spawn new child nodes from your selected nodes with that background information. So if you have an extremely dense bit of text, you can start with a general understanding of it and then select the nodes you want to do deep dives on and just go to arbitrary depth, learning more and more. So it's kind of like in your visual field, you see something from a distance, it's small. As you get closer, more and more details appear to you. So Newton reflects that.
Julien, I'm a big fan of Mark Hyman, Dr. Mark Hyman, because of all the work and all the advice he has for people like me in terms of healthy lifestyle and what I can I do without like making my life too complicated. I see his reels, his TikTok videos. My attention span is like 1 to 2 minutes. But I would like to kind of learn from the longer videos that he has. So how can I take a Mark Hyman video and learn from that without spending an hour on it?
You copy the URL, paste it into Newton. You have the graph generated in 3 to 5 seconds generally. And then just like that, you can step through those nodes and see, okay, this idea relates to this other one, this exercise technique or nutritional advice is related to these ideas and why. And one of the things about Newton that's so interesting is when you select a node, it will navigate to the source text that gave rise to that particular node and highlight it in the same color as the node itself. So as you're stepping through either the text or the graph, you can click on the text or click on the graph and then see where that corresponds in the other. So you can just quickly jump around and get everything you need in under 30 seconds.
Under 30, wow, that's amazing. So it can process like an hour-long video in about 30 seconds?
It'll process a 2-hour-long video in 5 seconds, and then you can spend 20 seconds clicking through and just enrich your own knowledge. Yeah, it's very snappy.
Yeah, it may take me 40 seconds because you may know that after a certain age, the brain's neurons start dying. So I'm 58 years old, so it may take me 40 seconds. Now, I also see text on your right besides the graph, which is on our audience's left. What is that text about? Right.
So that is a tool in the dashboard called interpretation. And there are a few options that you can select. You can also input your custom instructions if you'd like. And what Newton does is look only at the graph and then generate text based on the graph. So for example, if you happen to import an existing graph that doesn't have text, or if you happen to manually build the graph because you can create your own nodes and you don't have source text, that interpretation tool will give you text. This means Newton can go from text to the graph and then can go from graph to text. So you have that bidirectionality there.
Awesome. So what I see on the screen right now is basically 3 related representations of something of the same thing. So Mona Lisa, the picture, Mona Lisa, the knowledge graph, and Mona Lisa, the text that is related to that knowledge graph. Is that a fair way of looking at it?
Yes, absolutely. And so the interpretation is blind to the document itself. It looks only at the graph. And then also, if we were to go again to that doc type dropdown, change it from image to plain text, then we would see in the background the AI description that it gave for the Mona Lisa itself. So there's a lot of information there, and they're all just attacking the same concept from different angles.
Awesome. So my life in data science is kind of split between structured data and unstructured data, and obviously there's some haziness between the two. I kind of see videos as more unstructured data, and then I see like a Excel spreadsheet more or as a structured data. How is your processing of Newton different when you see structured data versus unstructured data?
So we treat them similarly by having the intermediary step of linguistic analysis. So we can take the structured data, import that, paste it in. You can see it visualized in the Markdown document type window. And then in the background, the same summary takes place, stepping through, extracting the core ideas, building the connections, as would take place if that information was represented in an unstructured manner. So again, the generality of language, a kind of focal point between all human knowledge, it's great for accepting any input type or format, whether it's structured or unstructured. And in fact, Newton also has a chat feature, lightning fast, highly intelligent AI. It can see everything in the document and in the graph. Or even if you select a node, it can see what you've selected and what you're asking about. So if you ever wanted to, you could even tell the Newton chat, take the structured data, convert it to unstructured, or vice versa. So it really is symbiotic. You can chat with your graph, you can accept any kind of input, and it's just explosive from there. Sky is the limit.
Awesome. Once I have the knowledge graph, I am not a pro at it. You are. And basically analyzing that and trying to understand that makes it a challenge in terms of choosing the right lens. So once the data is in, we see a default conceptual map. What is AI trying to achieve with this view, and what does that mean for me?
Right. So with the default conceptual map, the concepts themselves are parsed out. The fluff of the language, the expression, these sorts of things are put aside just so the key ideas can remain. And then the overall abstract summary of the concepts and their relationships are what's visualized. Conceptual map is just one type, though. And there are lots of different types of knowledge graphs that you can generate with Newton. There is an option for custom instructions. So if you wanted to have a concept map that follows particular instructions, maybe it would specialize on certain ideas, or you only want to look at things related to a particular node, then with the custom instruction setting, you can specify exactly what it is you want. So you're in control. You can have the AI really do whatever you want it to do in terms of representing information in a visual format.
What kind of document would be a perfect fit for timeline mode if I wanted one?
Okay, so usually I use PDFs. I like dropping in resumes that I'm writing or other resumes and just seeing the complete timeline extracted. So what Newton does for timelines is find chronological events and then connect nodes to them that are the descriptions of the events that take place. So maybe it would say 2020, you worked at so-and-so company, you also achieved these other things. So the timeline view is nice. There's a really interesting tool in Newton called topic clusters. So Newton will assess the entire graph and find holistic emergent behaviors from node neighborhoods that contribute to some higher order operation. What that means is that, say you have a timeline and then you go check the topic clusters, you'll see something like chapters of the timeline. So if you drop in a PDF representation of a resume, or if you just do import URL from a Wikipedia page to Napoleon Bonaparte's biography, or even if you type it directly into the document area, you'll get this timeline. And then it'll say things like early life in Napoleon's case, rise to power, so on and so forth. And you can find the actual moment where Napoleon crowns himself emperor. So it's really interesting to have things like timelines and then to combine that with the topic clusters tool, because you can see these emergent higher order behaviors that you wouldn't see at first glance. So Newton doesn't only represent the connections in your writing, it will also show you hidden connections that you may not have otherwise noticed, at least for quite some time.
Awesome. So I'm intrigued by the process flow mode as well, because it sounds powerful. It seems like I could take some code and I can give it, let's say, Python code, and it would generate a visual flowchart so that I can understand what the program is doing from a logical perspective. Is that right? And how does that work if that is
Yeah,
correct?
exactly. So the process flow mode, it's kind of like a traditional flowchart that you would think. You have some description of a process, a set of steps that follow some order. Maybe there would be decision points along the way, and the process flow will represent the entirety of that process. with step-by-step directions saying, if you're trying to make coffee, well, first you check, is there water? Yes or no? If not, fill the coffee machine up, then put in your beans. Well, do you actually have grounds, or do you need to grind the beans? So the process flow will represent each step by step. It's interesting that you brought up Python. So programming languages have their own kind of PEMDAS order of operations backbones called abstract syntax trees. What Newton will do is visualize the abstract syntax tree of a program so that you can see its logical flowchart in a visual manner. It's kind of like how the computer sees the program itself, step by step, saying, if this is the case, then trigger this. Maybe there'd be the definition of a function, some variables. And so then you're able to see the entire program visually. You can still click on a node. It will navigate to the source code because Newton also has a built-in code editor, and it will highlight that code. Whenever you combine the Python visualization with topic clusters, really interesting things happen because you start to see these higher order operations composed of smaller steps, these units of logic, such as functions, in a way that you couldn't otherwise do. So you can take a 3,000 line Python program, get the topic clusters. There'll be maybe 20 or 30 different topic clusters. You step through those and understand those, and boom, you understand the entire program. If you want to dig into a single topic cluster, you can do that. So the process flow is just like that. It's a sequence of operations, and then there's a lot of potential there. Newton does allow programmatic inputs, so there's a lot of potential.
Can you do this for other languages as well, or right now it's Python only?
So right now it's just Python, but there are already wheels turning in order to implement other languages the same way.
Yeah. So, in my language kind of life, I learned computer programming language on Pascal because that's what was used to teach programming. You can almost think of it learning a language as dating. So I was dating I was dating Pascal when Java came along, and I instantly fell in love with Java and switched to Java, and was really, really in love with Java, getting ready to marry Java for the rest of my life. And then Python came along. And I really thought that Python had no hope for it because it was just so simple and so crude at times. And now I see Python is all over the place. And in fact, even in data science, where I started using R, Python is replacing even R because of so many libraries and stuff are generated. So I think Python is just the best language for you to start doing this and learn kind of exactly what needs to be done. And then language is language. It's going to be just syntax that you can translate over to other things. The way I see it, I mean, it may take a little bit of time. Probably with a genius like you, 20 seconds. With me, it may take.
Well, you're too kind. Yeah, I mean, you are right. These programs and these languages are all built on a kind of Turing completeness, which means if you can do something with one language, you can replicate it in another language. Fun fact, though, Python is actually older than Java. It just goes to show how long it took for Python to gain that influence and finally snowball into what it is today. But it's because of Python's aesthetic sense. The creator of Python, Guido van Rossum, wanted it to be instantly understandable when you look at it, which is something a lot of other languages lack, although I'm sure they'll become a bit influenced by that Pythonic nature over time. But it just goes to show aesthetics can win. Form versus function, it depends.
You mentioned Turing completeness. And that kind of took me like a few years back. Who was Turing? Can you share with our people who Turing was? Because I think we owe a lot of programming things that we are doing to him.
Yeah, absolutely. So Alan Turing, this brilliant mathematician, he helped to solve this problem called the halting problem. So it was a bit of a philosophical paradox, asking if you can have a kind of emulator that calls other emulators if it will eventually know when to stop. And he was able to prove that you can solve it, and it actually does trigger a kind of loop. And the way that he did that was by inventing what was essentially the first computer. And so he invented the Turing machine in order to prove that the halting problem has a solution. And then it just so happened that the Turing machine is able to do everything else just because of the generality of it. So Turing was a great man.
Was Turing involved in the Enigma project in Great Britain, along with
Yes, exactly, same guy.
Okay, right, yeah, because there was also a bunch of chess players that were involved, like CHOD Alexander. But I found this to be extremely fascinating for a non-computer guy, but I'm also finding us out of time. So I want to thank, that's the reason
we have a halting problem.
Well, I look at Julien and I say, he's working to put me out of business. And Dr. Azhar.
Yes, he is. Fortunately, we are old enough. We are old enough. It's our children that we should be worried about.
That's true. And when you're talking about programming language, I think of COBOL and Fortran. Are they still around?
They are, yes. There's a lot of mainframe and legacy software that's still hosted by them. So they are more relevant than you would guess. But this has been fantastic. I'd be happy to come back. So again, everybody, www.newtongraph.com. Go check it out. Just for you guys, I put in a 7-day pro trial for all new users. So go sign up, have fun. Feel free to drop questions. I'd love to hear any feedback.
All right. Yeah. So we want to thank Julien and Dr. Azhar, and we'll see you next week on VC Masters. Bye-bye.
I go anywhere with you, 'cause you fill my mind, or you fill my mind. We could build a dream, start up something new, and the world is on your shoulders, and you feel like